Yeah, looks good. Okay.
Okay, good. Ok, salve 2 segundos. Bueno, pues, hola a todos. Actually, my name is Guillaume Morvan. I'm working with Rachid and Patrick with sediment modeling. Actually, I'm working on Legos in the same laboratory with them, and I design some configuration based on other model, not only CROCO, but I use also CROCO. And 2 years ago, I was working on some test cases, on the implementation of test cases with USGS sediment model. And that's it. So now maybe I will this. Okay, so the first thing I will show you some key points on whatever you want. If you want to do sediment modeling, but you are not sure, well, it's a good way to see some test cases. I wrote on the motivation. Yes, it's the first stage. If you want to, if you are a beginner, maybe if you want to do so, it's interesting if you want to test some flux interpolation schemes, over bed load formulation, and on the very cheap low environment, if you don't want to use a lot of nodes, for example. And also, it is interesting if you want to compare with other model. This is the case for CROCO because you have Mustang, but also USGS. So as Rachid said, I will talk about USGS code. What you see below, Rachid told already about that. Maybe just if you want to contact some people there, we are people, Patrick, Rachid, and I, for if you have some question for sediment, USGS, and the other community of the other model, Mustang model, with Solène Legac, Dumas, et Mathieu Caillou. But in this presentation, as I said, I will only present some test cases based on USGS. So you have to see this more like practical. Rachid was more theoretical. The important for you is to see how it is implemented and what's the purpose of each one. So I show you one table with some cases using USGS code. So you have the first one, planar beach and recurrent sandbar are originally there. On the last column, I wrote the process you want to study. So there we are the wave current interaction. For the recurrent, as the name said, it's for study of current recurrent with cross-shore and long-shore transport. And the sandbar, as it's not normally, it's sure. I will talk about that later. Sandbar and Rachid talk about that when it is important to see the migration of sandbar, and it's a case interesting because we have data. And also the migration with the activations of the morphodynamics key. There is also another family of test case, is a Dune. Our Dune test case is only, idealized Gaussian Dune. And 2D dimension, you have a 3D dimension also, but the idea here is to study with non-cohesive sediment bed load process, and the studies how they are sorted on the on the sediment layers with the best stratigraphy. With the other subcases analytical dune, you can also study different method of interpretation of flux, and that's it. There is another family, is a set toy of the ship case in the one column water. The idea here is to study processes with cohesive sediment, studying with suspended transport, consolidation, flocculation of the sediment. And on the last, I put some test cases with effects of tide, and we will see later. And the last one, this villain, I won't talk about that, but it's a Mustang test cases. I think you have the input on a tarball on the website of CROCO. So it's possible to do a realistic case also. So summary, yeah, okay, so it's the same. First of all, some analytical test case. So first the dune, next set toy with the mixed bed, and then tidal effects. And finally, I will talk about realistic configuration, and Rashid talk about that, about the configuration located on Vietnam. Okay, the first one is dune. On the right side, you have there, you have the section on the CPPDF file. So now I think you know this file. This is a section for the dune case, and you can change there the subcases, analytical dune and dune 3D. So the idea here is to simulate the migration, as I said, and to see how the front of dune, when you change your morphodynamics, you have a bed evolution. And then this idea here is to see how your dune will move regards with its front, and to check also the stratigraphy, as I said, how sands are sorted as long as the dune evolves. This is a picture and the 3D dimension. So you see on 2 days you have a move of the dune on the eastern part of the picture. And next, there is the analytical dune. This is to compare an analytical solution from a thesis from Marius, as I said, is to compare different methods of interpolation and to see if CROCO fit well with the analytical solution. So the dune test case by default is this one. So this is a scheme of your dune. You have a 2-meter height. You have on the bed there, you have 2 classes of sand, one coarser and one thinner, and you have a periodic channel with a barotropic flow there. So it's important for you also to remind you that if you want to change all this information of length of channel, of all the things I will say later for the domain and all that stuff, you have to change this if you want on the routine, anagrid, ana-initial, analytical, all this routine within the CROCO code. Okay. Another thing also is when you prescribe your number of layers on seawaters and sediment, important also to see if you analyze some outputs from CROCO. If you look at the index, well, you already know that the last one is the surface of your seawater, but of the column. But it's important to know also that for sediment, the first index is at the bed, okay? And just for your information, for Mustang, it's the reverse index management, okay? So for this case, as I said, we have a periodic barotropic flow. One key parameter is this one. This is the bottom roughness length. So it's fixed at -4. It's a key parameter because when you change this, you will change your shear stress and then your bottom stress. And this bottom stress will change. We evolve with the runtime. And we will see on in the name list, for USGS, Sediment June, for each kind of sand, you have this threshold. And as I said, your bottom stress will evolve, and depending if it's above this threshold, it will initiate the sediment motion. So it's a key parameter in this case. So I didn't talk about, Rashid already explained all the section of the name list of USGS. Only you have you have 3 meter height of sediment here, because you have 10 by 30 centimeter for each layer. With the 50-50 for each layer of sediment. In each layer, yes. In this case, we are using the formulation from Woolin with slope effects on lesser. So on the CPPDF, you can switch in this flag, and for result. So this is a result for 2 days. So as I shown for the 3D dimension on the introduction, this is for the 2D dimension. So in red, you have the native position of your dune or 2 meter, and you have your 10 layer there. And you see easily that you have a move of your front of 10 meter next 2 days. And for the color, it means that you have coarser sand in this place and below a thinner sand. Okay. So what we can learn about this case, and the other one, the subcase, is analytical. So as I said, the idea here is to study, to check if CROCO will fit well the analytical solution from Mario. So this is a scheme of the analytical solution. So you have a dune will evolve during time, and with very steep slopes. The idea of this case is both of them use the same formula. So the difference is to CROCO. Here we put the solution, the barotropic flow. And the idea here is to see when the CROCO process spatial interpolation of flux, depending of what method you are using, you will have different results. So in this is the evolution of the dune, and red, and the both cases we have the same analytical result, okay. And black, solid black line, you have the result using interpolation flux with first order, and the right and the 5th order. And you can see easily that you have a better result there. That 5th order get closer to steep slopes, as you can see. So it's interesting to test some different interpolation flux method. As Rashid talked about sandbar, this sandbar is another one. It's another test case where we want to see what's the changes or the impact during storm or post-storm conditions, and what the consequences if we have a sandbar on the middle of our domain. As he said, we have some data, some experience with different scenario of erosion, of accretion, and all of this depending of what condition of a wave, if you have high waves or if you have low waves, and it will determine in which process it involves your sandbar. So here you have your scheme, and the idea is that two different ways to force sandbar. So you can use the WKB wave model. So it's a monochromatic wave model. Here, when I talk about wave statistics, is only using peak period and significant wave height. This information are force the western part in this part, yes, and the hydrodynamic with the wave current interaction will initialize a bottom boundary layer near the bottom there. There is another way to produce this is to run sandbar in non-hydrostatic mode, NBQ. So the idea here is to resolve very explicitly the velocity at the bottom, but the counterpart is you need a high resolution and also a lot of this kind of strategy will need a lot of nodes, a lot of processes. So it depends of your computer. In this case, I talk about only about the wave statistic. So what happened there on the top? You can imagine a linear slope, and for the first scenario of erosion, we apply high energy waves. So this is the wave information you apply there. I put also the DIN number. So this is information, a relation between wave significant height and peak period and settling velocity. Settling velocity is constant in this case, and the idea is to see the differences, the competition between erosion and accretion. So we see that in this case, that the DIN number give us a high number, meaning that we have erosion. As Rashid said, here we have initial in dot point we have our initial bed, and finally in black the model CROCO give us a migration of sandbar offshore in this direction. And is according to the data we have. And again, 18 hours later, we change the forcing on this side, and we put low energy waves, and this means that we have accretion and a transport in the other part, a transport onshore of the sandbar. So I think that's all for this. Yes, and this is to show you, yes, the different data, validation with data. So we have, according to the root mean square wave height, we have slightly the same result. CROCO sees the undertow. And the associated with the undertow, we have more material on the column of water. made in suspension. So that's the result of the validation, and that's it. And that's it for this. Yes. Another family of test cases is, as I said, it's a set toys. It's a cheap test cases where we are using just 1 column of water and the cohesive sediment, and we try to see some processes. So first, you can see also on the CPPDF section the different key we have. So we can choose to see if CROCO fit well the rules theory, to process the consolidation, flocculation. That's it. So that's the different key you have to switch on. Okay, for the rules theory, as Rashid said, we can see the sediment like a diffusion problem with higher concentration at bed and lower at the surface. So we can compute some profile, a theoretical profile there, respecting of this theory, and associated in this, you have a rules number depending on the settling velocity and the shear stress. So the idea here is to see if USGS fit well the rules theory. So before to show the result, we have to I have to show you what we put on the name list dedicated for these test cases. So we have the same concentration on the column of water, but we have different settling velocity for each one, for each mud, for each cohesive class. Okay. So here is for each class of mud. So first of all, we can see that it fits pretty well for each kind of experiment with respecting the settling velocity. Intuitively, we can see that when you have more settling velocity, it deposits quick. So you have lower concentration on your column, and it's the inverse in this case. And I put also the rules number there for information. Voilà. Alors again, there is another test cases. This is for consolidation. The idea here is when you the idea is to modelize the cohesive behavior of your sediment. Okay, and we will see that if you change the behavior of cohesive sediment, you will modelize some consolidation on layers of sediment. The idea here is normally before you have seen that each sediment, each class of sediment have its own erosion rate, right? The idea here is different. Is we said that erodibility is a property of the bed layer. That means that each layer has its own erodibility, its own erosion rate. Okay. It means also that you have also a critical shear stress for erosion, different depending of where you are on your sediment layers. Okay. And all of this is managed with the bed module, the cohesive bed module implemented in USGS. So quickly, normally you initialize your module at the very beginning. You only have to change some information on your name list, your dedicated name list sediment.in. For this case, for consolidation, you have to change some information. So for this case, normally you don't have to change anything. It's for this test cases, it is constant. It is already on the name list. So this kind of parameter will build a shear stress at equilibrium for erosion. So you will have at the very beginning this shear stress profile like a reference, and each not each, but user can change time scale for the number of seconds of days to process consolidation or swelling. Swelling is the inverse. When layers are more thicker. So here we are at the very beginning, and during the runtime, we apply a stress, and the stress go on the bed, on the sediment, come to the sediment, and as we can see, we will have on each layer of sediment a new profile, and this profile will evolve in time. Okay. And the module will nudge all this profile to the equilibrium, in this case, with a time scale characteristic that user already defined on the name list. So when we are here, we are on eroded profile, and when we are here, we are on deposit profile, and we are in the property of the sediment are different. There are more consolidated layers there. So for the test cases, we apply on the top, we have the bottom stress. Okay, so we apply a stress there. Below, we have the same of this, but for it's a two profile of critical shear stress. So in all this plot, the red line is the same. The only thing that changed, but is a critical shear stress that evolved during time. Okay, so at the very beginning, we are here. We are slightly close to this equilibrium. We begin to erode because we have stress. So we erode our bed sediment layers, and we put some materials on the column of water. So we are lost there. We can see there we have an eroded profile. We have this part of this scheme, and days are going, and on the 32 days, yes, we see that we are nudging. The profile is nudged with the equilibrium, and then the experience said that we stop the stress. What happened then? When we stop the stress, all the material on the column of water will deposit. Not all, but a part is depositing there, and we can see that we have a change of our profile, and regarding to the thick of the layer is totally different. And so we can see that in the next 38 days, we are consolidated layer there. Okay, according to our time scale, it was 33 days. Okay, so that's an example of to modelize the post-consolidation. There is another one is to study. This is a new one because there is some work with people from Brest for the study of flocculation, and And of this test cases we want to modelize flux. Our flux is only just aggregate of mud sediment classes, and we want to see how they will redistribute. It will be redistributed depending on which process you have. So you are mainly, as I wrote, there are mainly two mechanisms of aggregation, of fragmentation. On the right, you have one flock there, and there's another one there. And we see that in aggregation mode, we have so changes of property of flock in mass, and this flock is redistributed in another class. So what does it mean? It means that anytime and anywhere on your column, you will have redistribution of the distribution. The distribution of your material, and we see on the next slide. In this case, to force this, we use the tidal forcings. As I said, we see in time the evolution on the redistribution of the flux. And I put this, yes, because on the estuary, because this is a region where a lot of mud, and for these cases, this kind of experiment or study, it's important to take account of flocculation, because there are this important process in this area. Yes. So to initialize it, we are using 15 classes of mud from 4 micrometer to 1,000 blah blah 500 micrometer. And what happens? So on the top here, you can see it's a shear stress. So it's a shear stress there during time. Okay, you can see the shear stress like the tidal forcing stress. Okay, below you have the shear rate. The shear rate on the column, so the 5 meter there, 5 meter, and intuitively we can see that the shear is more important at the bottom there. And during cycle, when there are tidal forcing there, there's a shifting in time. Regarding for the resuspension of material on the column of water, so you have more material there next to the peak of stress. But what is interesting in this is also to see, well, I put the flock median, the median of the older flock, and it gives you this information for any time and anywhere on your column. So mainly, what we can say that when we have here, you have no tide, we have more flock. No, more flock. No, it's not more flock. It means that your flock, the size of your flock is higher. Okay, and when we are tide, is forcing there is lower. Okay, so this is the first information. The other thing is you can see as to understand what happened is when you are here. It means that you are at the end of the tidal forcing. You are at the surface. You have a shear rate with low value, but you have at the same time a quantity, important quantity of material there, and we can see that in the flock there is value are high, but higher than at the bottom of the column. And what we can see there is, so this is a median value, okay? But at any time you can construct the fraction of each size. Each size class are present on the feed there. So it means that when we are here, we are a change of classes of modes. So we are more flock in these cases, in these classes. Sorry. This is at the surface, and it's totally different at the bottom. We have the change of a distribution there, with lower values. So this is an example, and that's it for set toy. Sorry. The next is for if you want to. There are some test cases if you want to see the effect of tide cycle forcing. So I put there tidal flat. So tidal flat. So again, you have the section on the CPPDF file there. Simply, it's to see how your tidal cycle will change your concentration of sediment on the water. So again, you have a discretization there. To the dynamic, we have flat bottom. We are using flat bottom, and for the tidal cycles, we are using this formula to reproduce a tidal cycle. So we initialize also with some kind of sediment. Here we have two non-cohesive sediment and one cohesive. Okay, but the most important is here to see that when you force there on the western part, we force with tidal cycle. We see that you have U barotropic U velocity higher when tides go on shore, and is related to less of materials on the column. And as you can see on this off-molar, we can see all the cycles and the anti-correlation between the tidal effect, the tidal cycle, and the concentration on the water. So this is one of an example. There is another one. Now this is estuary. This, as Rashid said, and I think in the first presentation, yes, he talked about a sediment pool, because when you study estuary, this is a kind of not effect, but it's kind of thing that it happened. You have a pool there, a concentration of high concentration of mud happened there. So these test cases is to show to understand what happened, and what happened there is we put some sinusoidal tide. It's the same. We put sinusoidal tide to reproduce a tidal cycle, and as we are in estuary, we have also a runoff value with low salinity value, and we also put an input some mud concentration. So we initialize this test case. Normally, yes, we have no sediment on the column, but we initialize it just with quantity on the bed with 40% of sand and 60% of mud. And I only put this to show you how to prescribe sediment on the CROCO.in file. You can put information of quantity of mud you want to put in this case for the runoff. I put red, blue, and green. Of this point is for the evolution of each part in terms of theta, in terms of stress also. So in red we are there, so we are offshore, and we still have the same phase, and we see that if you are going there, we have an asymmetry of the tidal cycle. We observe also an asymmetry of stress. This you can imagine this is a cycle of tide. We have differences here in stress, in terms of stress, and okay, and what happened here is this is a transect at time there on the solid black line in one time there, and as Rachid said, you have at the bottom a baroclinic transport, but also with the fact that you have runoff, low salinity, you have also a bottom current on the other sense. So what happened is I don't show you all the video, but you have more or less the same quantity of value of sediment, of mud on the water, and in the remain at the center. So what is one thing, and I finish with this. This is one configuration based on CROCO using USGS. As Rachid said, is center on the south of Vietnam. We study here the Mekong River and the interaction between tides and waves. In this configuration, I don't talk about all of this, but the idea here is we have two kind of type of sand, one sand and one mud, two class of sediment. And as Rachid said before, the idea here is to study the redistribution of the input of sediment from Mekong, and to see how it is distributed along the shore there. So whatever you have differences between on the coastline there. So in blue you have more accretion, and red erosion. So this, it is the net deposition. So this is and the same from Rachid, validation, differences between product of satellite MERIS. This is using a surface particulate matter, but you can consider that is the same that sediment concentration at the surface. So we can validate or configuration like that. And it's this last one. Well, this I give you some key to begin some that these test cases. But you can, as you want, you can create your own. On your own, you can see on the literature, create your own test cases, and use, as I said, you only have to change on some time, like anhydride there, annihilation, ethical, or you can play. You can also change the existing test cases depending on what you want. So creo que ya está. No sé si tiene alguna pregunta.
Thank you, Guillaume. Questions, comments? Which is your favorite case? Which is your favorite test case?
Favorite case? No, I work a lot with June. No, because I like because it's very intuitive because you see that when you change you just switch on the morphodynamics, you will see your bed evolution and the stratigraphy also, the changes on the how they are sorted on the sediment. No, I don't know. This one or I don't know.
There's a question in the chat. Let's see. First one.
Considering the effects. If you want to simulation with different wave approach.
How to modify the angle of the wave if you use wave current interaction?
Well, it depends how you specify the input wave data. With CROCO, you have so you can couple CROCO with wave watch, but there is also a monochromatic wave model inside CROCO. It's called WKB, and this model can take input file or analytical value in CROCO.in. So basically, in CROCO.in, you can specify the wave height, the angle, and the period of the wave. So it can be a way to do experiment with this. So if you use, I think if I had to do this, I would do this actually. To use this embedded wave model, which is in CROCO, WKB, and play with the value in CROCO.in.
The second one, inflow of sediment from a river. Well, I understand you can change the sediment concentration in the CROCO.in, but can you do that also in the netcdf file for if you want to read the river outflow from a netcdf?
I never use.
So you can set.
I think yes. I think it's like any other tracers, like biogeochemistry, temperature, salinity. When the sediments are in the water column, it's like every other tracer. So I think it should work. I know it works from the CROCO.in. I think it should work from the netcdf, unless there is a bug.
Possible. Yes. Any other questions? Well, if not, well, thank you very much, Guillaume. We will practice some of these cases. We will do the demonstration of some of these cases in the afternoon, and as you have shown, people can just play with them on the code. So we will see the practical steps on running test cases and making plots. And I think that's for the.